Okay, so we're going to continue looking at inequalities today. So remember, none of the problems that we solve are going to have an equal sign in them. Right? They're all going to have one of the four inequalities. Okay? Can someone remind me again? Give me one of the inequality symbols. What's one of them? Joe?
Greater than.
Greater than. Yep. What's another one?
Less than.
Less than. Yep.
Greater than or equal to.
Greater than or equal to, and
Less than or equal to.
less than or equal to. Perfect. So, how would you, based on the symbol I have there, how would you read that one?
Oh.
How would you read that one, James?
A is less than B.
Yeah, A is less than B. Now, instead of less, you could also say fewer. A is fewer than B. Less than is what we use most often now. So, if you wanted to think about this on a number line, okay, A is to the left of B. Right? If I made a number line, A would be here, B would be there. If a number is smaller, it's always to the left. Doesn't matter if it's positive or negative. If you've got two numbers and one of them is to the left of the other one, then it's the smaller one. Okay? Always smaller to the left. The number that's over here is always bigger. The further to the right you go, the bigger you get. All right, how about that one? How would you read?
C is greater than.
C is greater than D. You could also say C is more than D. And now if you did that on a number line, where would C be if it's bigger than D? C would be further to the right. Right? C is bigger than D, means it's over here. It doesn't matter what those numbers are, if they're positives or negatives. If C is bigger, it's further to the right than D. Okay. Any questions on that? All right, so let's look at an example. So, to solve an inequality, okay, it's kind of like solving an equation. Solving an inequality means to find the solution set. Now, why do you think I say set when we're talking about inequalities? I didn't just say find the solution. Like when we do equations, we usually just say find the solution. Why do you think I said set here? James?
Because most inequalities have one answer.
Right, most inequalities have more than one answer. Right? If you got an answer like x is greater than 2, well, how many numbers can you think of that are greater than 2? There's more than one, right? There's a lot. So we call all those answers the set. Okay, so set just means that there's a bunch of answers. It's usually all the numbers that are bigger than something or smaller than something. So we just have to figure out which way it's going to go. All right. So when we are solving an inequality, what do you think we're trying to get by itself? Same thing we have to get by itself in an equation. Yeah, Lucas?
The variable.
The variable, yep. We're trying to get the variable by itself. And then I put preferably on the left side of the inequality. We've talked about that a couple times. Why do you want the variable on the left? I mean, you can put it on the right. It's not wrong, but it's just better if you put it on the left because, yeah?
So when you put the sign, it shows which way it's going?
Yeah, it shows if you put the sign, it shows you which way you're going to shade. Okay. If you put the variable on the right, you're not wrong, but now it's going to tell you the opposite way to shade. So if I were you, I would just stick with putting it on the left. Okay, but that's the goal. We're going to get the variable by itself. Now, if you looked at the title, today we're going to be doing two things to get the variable by itself. You're either going to add to both sides or you're going to subtract. Right? And this is going to work just like when you're solving an equation. All right, so you don't have to write down. I'm just telling you that it's exactly the same as when you're solving an equation. Now, tomorrow we're going to do multiplying and dividing. When you multiply and divide, there's one thing you've got to be careful with, and that's negative numbers. Right? Negative numbers don't really matter today. You just do your arithmetic and you'll be fine. But when you have multiplying and dividing and there's negatives, we got to be careful because something happens. Okay, but we'll see that. Let's see. Okay, we'll see that tomorrow. Okay, so not every problem on the test is going to say solve and graph. Some will just say solve. But if it says solve and graph, make sure you solve it and then graph it on your number line. Okay, so the reason we can't graph this one right away is because the variable is not by itself. What's with the variable that we don't want? We don't want the negative 8. Okay, we want to get rid of it and put it on the other side. So what operation is negative mean? What are you doing right there? Yep. That's subtracting. So you have x minus 8. So how are we going to get rid of the minus 8? Yeah. Add. How much?
8.
8. And where are you going to do it?
Where the x side is and where the numbers.
Yep. So we're going to add it on both sides. If I do that, Kayla, what's negative 8 plus 8?
0.
0. That's gone. So we just cross it out. That's why we did it. Kelsey, what's still on the left-hand side?
Negative 11 plus 8.
That's the right.
Oh.
Left.
X.
X. That was the whole point, right? Now we got x by itself. And for today, you keep the sign exactly the same as what it was originally. Okay. Tomorrow, we're going to learn sometimes it has to flip, but not today. So just keep it exactly the same for today. And then how about, Jaden, what's negative 11 plus 8? Negative 3. Okay, so that's the first part, solve. Any questions on how we solved it? All right. Now we're going to graph it. Now, sometimes on the test, your number line is already going to be numbered for you. If it's not, you just have to put some numbers on it. I would probably just go like 0, 3, negative 3. I usually do something like that. Okay, what's the first thing we have to decide when we're going to make a graph? We have to decide,
Where the dot's gonna be.
Okay, we got to decide where we're going to put our circle. So where does the circle go? Kelsey?
On negative 3.
Okay, so I'm going to put a circle on negative 3. I agree. What kind of circle? An open or closed? Lucas? How do you know?
It's not like the equal to or less than.
Yeah, not the equal to. Okay? So we put an open circle on negative 3, which means you cannot include negative 3 in your answer. You can only include numbers that are less than negative 3, not equal. Now, which way do I shade? Where are the numbers that are less than negative 3?
To the right.
Which way did we say are numbers that are always smaller? Smaller numbers are to the left. Okay, smaller numbers, always to the left. Okay, if you shaded right, okay, what I'd do on the test, I'd give you half, because you got it, if you got this part right, but then you got the graph wrong.
But could you shade to the right?
If you had this as your answer, then you would shade to the right.
Wait.
Because greater than, when you put the variable on the left, means shade right. But less than means shade left.
Got it.
If the variable is right there. Okay. Any other questions on that one? Now, when would this be a closed circle? If I had what? Yeah. If I had that, now I would do that. Okay, I'm going to put it back the way it was. But if I had the little line under it, then I would shade it in. Okay. Let's look at this one. Okay, I'll probably give you guys time to try a couple on your own because they're not, these aren't super long to do, so we'll have time to try that. Okay, is that one ready to graph? No. Okay. It's ready to graph when what?
You add
So not just specifically in this one, but in any problem, it's ready to graph. No, it's ready to graph if, yeah,
the letters by itself.
if the letter's by itself. Okay. If the letter's not by itself, it's not ready to graph yet. So how about Leilani? What would I do here to get the letter by itself?
Add 2.
Yep. I'm gonna add 2. I'm gonna add 2 on both sides. And Tristan, -2 plus 2?
0.
0. You don't have to cross it out. I usually just cross it out because it's gone. And Princess, what's on the left side now? B. Perfect. That was the whole point. What do I do with this symbol?
Bring it down.
Just bring it down. I don't do anything to it other than copy it today. That's it. Just copy it down. And Mackenzie, -2 plus 9 gives me how much?
You said that wrong.
Yes, I did. -9 plus 2. Let's try that.
-7.
-7. Yep. Okay. So there's the first part. We solved it. Be careful what happens there. Sometimes people do kind of what I did. If the negative gets too close to the 7, it's hard to tell if it's a negative or you just drew the line too long. So I'm going to try to make it look clear. -7. Okay. Now we got to decide on our graph. So Sophia, what should I do on my number line first? Yeah, we should put some numbers there. So I would just usually put 0, 7, -7. I mean, if you really want, you could number -6, -7, -6, -5, -4, -3. I mean, you could number the whole thing if you want. That's fine. All right, so we got that. Gianna, what kind of circle on this one? Closed. And Stephen, what number is it going to be on?
-7.
Perfect. So closed circle on -7. And Olivia, which way do I shade?
That way, I think.
To the
Right.
right. Okay. Everything that's greater than or equal to -7. Greater numbers are to the right. Okay? These are bigger numbers than -7.
Wait, so you always draw the arrow, in the direction that like the thing is pointing. Okay, yeah.
So the question, do you always draw the arrow in the direction that points?
If the letter is on the left.
Perfect. If the letter is on the left, yes.
Okay.
Okay. If you did your problem like this, you put the number on the left, and you put the letter on the right, and it's pointing at the -7, pointing at the -7, I would give you credit for that. That is correct. That and that are the same thing. But I think what's tricky about this is it's pointing to the left. And you might think, oh, shade to the left. Well, it's not set up the way it should be, all right, in order to give you the hint at which way to shade. All right? So I would stick with that. Yes?
Do you have tissues yet?
I have the paper towel, that's all I have. Yeah. Any other questions on this one?
Aileen.
Oh, yeah, we got
Oh,
some.
thank you.
We got a generous Good Samaritan. There we go. Okay, why don't you guys try 2A? Okay, solve and graph. So it says y plus 8 is less than or equal to 5. Okay, so take maybe like 60 seconds. I'll walk around and see if you guys can solve that. Now, does it matter if they used y or if they use x or in this one they use B. Does the letter matter?
No, it does not.
No.
No.
Unless it's L.
Yeah, the letter is just there to tell you that it's a variable. It doesn't matter which letter they use. What I will not do though is I won't use a letter that would look like a number on a test. Like I would not use an O here because that could look like a 0 and then gets confusing. All right, so first question we had was, is that already by itself? And we decided that it was or it wasn't?
It's not.
Not yet.
No.
What do you have to do on both sides to get it by itself?
You have to subtract
Subtract
8.
8.
Yes. You always do the opposite operation, okay, when you're doing something on both to move it to the other side. How about, let's see, I've called on a lot of people. Let's see, Julia, what's negative 8 plus 8 minus 8? 0. That's gone. So now we have y. And then how about Adriana, what's 5 minus 8? Negative 3. And what do I do with the symbol?
Just move it down.
Just copy it down, that's it. Again, it's going to change a little tomorrow, sometimes. But for today, always just copy it down. Okay, so are we done?
No.
No, we got one more thing. Solve and graph. Okay, just read the directions. If it says graph, I'm usually going to give you a graph. So you won't forget to do it unless you miss seeing the graph that I gave you. Okay, I'm not going to give you a solve and graph problem and leave the graph like off the page. Right? If I put the graph there, then I'd like you to fill out the graph. So Kelsey, what's the first thing I should do on my number line?
You should write the numbers.
Yeah.
0.
Yep. So I would just go 0, 3, negative 3. If you want a number, negative 3, negative 2, negative 1, 0, you could do that. That's fine. All right. So we got our numbers. How about James? What do I got to do next?
You gotta make a closed circle
Yep. How'd you know closed?
because it's equal to.
Okay. So there's my closed circle right there.
No.
No. You just said make a closed circle.
Make a closed circle under or over negative 3.
Yeah. So put the closed circle on negative 3. Are we done the graph now?
No.
One more step. Last step?
Yes.
Shade. Yep. Which way do I shade here? Left. Okay. So the y is the answer, right? Your answers are less than or equal to negative 3. Just think in your head, where are the numbers that are less than negative 3? Less than is to the left. If that said greater than, we would have shaded to the right.
I did it to the right.
Any question on that one? All right, let's try, so we got one more like that. Okay, so this one says negative 8 is less than 1.4 plus m. So it's a decimal, but I mean it's not an awful decimal to work with. So take a minute and see what you can do with that one. And you got a couple choices how you start this. If there's an optional step here you could do because it's not written the way we're used to writing it. So you got an option, right? So we'll talk about that in a minute. Okay. What's different about 2b compared to, we did 3 other problems so far. Well, this one's different.
It was opposite.
What do you mean it's opposite?
It sort of explains itself and it's opposite. Like it's like flipped around.
Flipped around. What's flipped around? Like the sign is flipped?
Yeah, like the M should be on the other side.
Oh, the variable's on the right.
Yeah.
Okay.
But
So
that's okay.
we have a choice. We can either do the problem the way it is, like that, or we can rewrite it so that the variable is on the other side. If you rewrote it, okay, we'll call this box 1. We'll call this box 2. You just take boxes 1 and 2 and switch them. Everything that's in them. So take box 2, put it on the left. Take box 1, put it on the right, And now which box was the symbol pointing at originally?
-8.
Right, it's pointing at the -8. So when you do that, it's still pointing at the -8. If you want to do that to start the problem, you can, right? That step is not really math or arithmetic. You're literally just taking two things and switching them, all right? But remember, when you switch them, keep the sign pointing at what it was pointing at originally. If you don't, then you didn't, it's wrong. Okay, so it was pointing at the -8, still pointing at the -8. But either way, you can solve it. Yep.
For the m, well, the 1.4 plus m, if you put the m on the other side and the 1.4, like you switch both of them, when you like flipped it, does it really matter?
What do you mean? If you did what?
Like
You can do, this is okay.
like
Did you
the-
switch the m and the 1.4?
Yeah.
Yeah, I mean, that's technically okay, because that's the commutative property. If you had like 2 plus 3 and you write it as 3 plus 2, technically that's the same thing. Right? I usually just keep it in the same order that they had it. But, okay, so regardless of which way you did it, what's your next step to get m by itself?
Oh,
One step. That's all we gotta do, one step.
Minus 1.4 on both sides.
Yep. Now a little tricky because we've got that -8. So we've got m is greater than. Anyone think they got -8 minus 1.4? So remember, when you have a negative number and you subtract something, it gets even more negative. So you're going to get a number that's further to the left. Yep.
-9.4.
-9.4. Okay? Now, would you get the same answer if you solved it the way it was set up originally?
no.
Oh, I see.
If I don't get the same answer, then that means I messed up here. Because you should get the same answer no matter which way you do it.
Oh, do you mean like if you didn't switch it? What
Yeah.
Oh.
So like if you minus 1.4 and minus 1.4, now you have this.
Couldn't you just switch them at the end though?
You could just switch that at the end now. That's exactly the same thing. Look at your number, same number. Look at your letter, same letter. It's pointing at the -9.4, pointing at the -9.4. Which one do you think I like better though? The one on the left or the right?
Right.
Why do I like this one better?
Because the M is letter, symbol, number.
Right, it's letter, symbol, number. So the symbol tells me shade to the right. Okay? All right. So now when we do our number line, we're going to have to put it in the middle, right? It's a decimal. So let's just go like this. -10, -9, -8. Where's -9.4? In between which two? Yeah, in between -9 and 10. A little closer to which one?
9.
Little closer to -9, right? So we'll put our circle
Can we just like
right there.
put 9.4 on a line?
I did the same thing.
Yeah, you could.
Oh, the
You could. Usually when we number lines, they usually use numbers like that don't have decimals. But you could put decimals on a number line if you wanted.
It just takes a long time.
Like if you put 0.1, 0.2, 0.3. I mean, you can do something like that. I just get confused with all these decimals. It looks kind of weird. But you can do that. Yep. Yep. Now I got my open circle. Shade which way?
Right.
Yep, we're going to shade all numbers that are bigger than -9.4. These are the bigger numbers. Okay, any questions on that one? Yeah.
Well, what classes, like, what type of classes do you teach when, like, the week we have shop?
You know what? I'll show you a little chart. I have a chart of every math class in the school. I can point to which ones I teach. But basically, pre-calculus and trigonometry. Yeah. I've taught other things in the past, but that's pretty much the two that I have taught for a long time now. Yeah. Hey, any other questions on that one? Okay, so let's look at this one. I think you guys already have this. Yeah, you should already have it written. Okay, so this one's about electricity, right? If you've got like a circuit in your house, you might have like a circuit breaker or a fuse panel. And like sometimes during the summer, like if your air conditioner kicks on, like the fuse or the circuit breaker trips because it's too much electricity. Well, that's basically what this is showing us, right? So this says that a circuit will overload at 1800 watts. Okay? That's when it overloads. Right? So you plug in a microwave that uses 1100. So is that okay on the circuit? Yeah, it's okay, right? You can use up to 1800, you can't go over. But 1100 is definitely under, so that's okay. So now it says, write and solve an inequality that represents how much more electricity you can use before the circuit overloads. All right. So what do we know about the amount of electricity that we use on this circuit? It's got to be what?
Equal to or less than
Less than or equal to how much?
18,000.
So-
1,000.
Can it equal 1,800?
Yes.
When would the circuit overload?
At 1,800.
At 1,800. So we want to make sure that we use less than that. Okay, so what I'm going to do is just kind of write that idea down. So the electricity we use has to be less than 1,800. Now let's write down the electricity that we're going to use. How much electricity have we already used in this problem?
1100.
We've already used 1,100. Can we use any more? We still have more to use. So if we have more to use, we're going to put something here that represents an amount that's unknown. So what do I need right here? X. Now, if you have 1,100 you've already used, and you have X more that you can use, what symbol should you put between the two?
Wait, shouldn't there be a line under it? Because it can all, like, it can equal.
Well, this says that if you hit 1,800, the circuit overloads.
Okay.
So if we, it's kind of how you interpret it. But I'm interpreting it as if you hit 1,800, it's too much. So
Okay.
you can only go to like 1,799. Okay. Yeah. Yeah. This is how much you've already used. Plus you can use some more. How much more exactly, we're going to figure out. But you just have to make sure you stay under 1,800. So this is the right part. We've written an inequality. Now how would we solve that to get x by itself? Yep, what would we subtract? 11. What is that?
1100.
Yep, 1,100. And where else do you subtract it from?
1,800.
From the 1,800. Okay, so that's going to give me x by itself on the left. And what's 1,800 minus 1,100? 700. So what does that mean?
You can use 700 more watts of electricity.
Right, we could go, as long we have to use less than 700. So we could use like 699 or less. Okay, so less than 700. So x is less than 700 watts. Yep.
Isn't 1,800 very, very low? That's like a...
No, that's 1,800 watts on a 120 volt circuit would probably be close to 15 amps. So most house circuits are 15 amp is pretty common. On your microwave or your fridge circuit, it's probably a 20 amp, so it can handle a little bit more.
Yeah.
And then on like your, if you have an electric stove, that's different. It usually is, it's a 240. So it's
Amp.
same with an electric dryer.
I was gonna say, that's really low because 1,800, because just the microwave takes more than half.
Yeah, most microwaves, like my microwave takes about 1875.
Yeah. It's
So like if I tried to plug two microwaves in on the same circuit, it would most likely blow up the circuit.
Blow up?
Yeah.
Microwave frost light, yeah, it's gonna explode.
So usually in a house, what controls how much electricity you can use on the circuit is the thickness of the wire. So if you have a 15 amp circuit, the code for that, most of the time, the wiring is white. If you have white wires and you see them, most of the time that means it's for a 15 amp circuit. And then if you go up to like a 20 amp circuit, I think it's yellow. Right? The color most of the time they use is yellow, a little bit thicker gauge. And then you can go up to like a 30 amp, and that's orange wire. So like I have a separate circuit in my house for my generator, and I ran an orange because it's a very thick wire and it's made to power lots of circuits. But white is the most common. It's a 15 amp basic circuit. I don't know what the outlets. Actually, I can tell you a little bit about the outlet in this room. We're getting a little off track, but that's okay. Most outlets look like this, right? Well, that's what a 15 amp outlet looks like. If you look at the outlet in this room, it looks like this.
Looks like glaze.
It's got like this little side notch on one of the outlets. That little thing there tells me that I could plug in 20 amps into that outlet. Because obviously I can't see the wiring. I don't know what the wiring is behind the wall, but I can see the outlet. And that means 20 amp.
30 is like a whole house.
I forget what they all look like. They have all kinds of different ones. They have RV outlets. They have outlets that are called a twist lock, where that's a big one.
Those are the child lock ones.
They got
Those are the normal 15.
yeah. The twist one, sometimes it has 4 on it, and you put it in and you turn it, and it locks in. A lot of generators have that.
Yeah.
Oh.
That's usually like a bigger, a little more
Olivia's
power.
plugs have like child locks because they look like the normal ones.
But you have to like stick it in and then turn it and push it in.
Yeah,
She's
yeah. They got different safety things.
Is your whole house like a generator?
Well, no, it's not hard. It literally looks just like
So
that, but there's just like any
If you're in electrical or you take that shop, you'll learn all about that kind of stuff, like the wiring and that kind of stuff.
grandma.
My grandpa.
All right, so okay, we know how much electricity we can use, right? You just have to use less than 700. So they give us a chart, and they want to know which things can we plug in one at a time without overloading the circuit. So not all together, but we have to use less than 700. So could we run the clock radio
Yes.
with the microwave at the same time? Yes. So I'm going to say yes. Could we run the blender with the clock, with the microwave? Yes. Could we run the hot plate? No. Could we run the toaster?
No.
No.
Toast?
Now, if you look at these, right? You look at the clock radio. Clock radio hardly uses anything, right? That's like almost like a light bulb in here. It doesn't use much at all. Notice the things that use more electricity. Blender has a motor. Okay? Anything that has a motor in it, that's going to use more electricity. Okay? And most of the time when you have a motor, the second you turn it on, it draws a lot of electricity. Right?
What about
It's
chargers?
like a surge.
That's like
Okay, anything that has a motor, the second it turns on, like if you got a pump in your basement, like if you get water or something, the second that pump kicks on, it draws a lot of electricity, and then it kind of, electricity goes down a
What about
little.
like phone chargers?
Phone charger, hardly anything. Very little, maybe.
Yeah, because they're really small wires.
Yeah, very small. Now, like a hot plate, there's no motor in a
What's a
hot
hot
plate.
plate?
It's like something you can plug in and like boil water on it. It's like a single burner stove. So the reason a hot plate uses a lot of electricity, there's no motor in it, but anything that gets hot, that heats up, toaster, hot plate, if you have like a griddle that plugs in and it's electric, those use a lot of electricity. Space heater, ton of electricity. Electric fireplace, ton of electricity. Okay, things that heat up or things that have motors in them use a lot of electricity. Yeah.
Okay, so you know, there's a, like, okay, I'm talking about Apple phone. So an Apple phone charger is like a tiny square, right? But then an Apple tablet phone charger is like a bigger square.
Yeah.
But would the bigger square make it charge faster than the tiny square?
Not necessarily, no. It depends on how they made it.
It's just clunky.
One thing that's a little complicated with that, which
Now they have
we
smaller.
don't talk about in this class at all, but those like bulky things that you plug in, they take the electricity that's in the wall and they change it. So there's two kinds of
A
electricity.
little electricity.
Has anybody ever heard of like alternating current and direct current?
Nope.
Yes.
So the difference, alternating current is the kind of current in this room. Okay? Direct current is the kind of electricity in your car. Okay? It's the kind of current in like a battery. So that's a little different. But yeah. Okay. So any other questions on this one? Okay. So take, we'll try these extra examples. You got some room on your notes. So take a minute. I'm going to try to put them all on the screen at the same time. Right.
Do we have to graph? Oh yeah.
And like crack open right.
Okay, so guys, a couple quick reminders, all right? So worksheet tonight on 2.2. We already did the extra examples. Test on Friday. No review day this. Yeah, actually, we are going to get a review day on Thursday. So Thursday. Actually, let's just go like this. Review day this week on Thursday. Bless you.